Hey guys, today we're doing something similar to what we did yesterday. The only difference is that now we're going to be looking at non-proportional situations, whereas yesterday we were looking at proportional situations. So we're going to be analyzing and representing these non-proportional situations in several different ways, with tables, with graphs, and with equations. And remember that the equation for a non-proportional situation is y equals mx plus b. So m is your slope, which is the same as k, your constant, and your plus b is your y-intercept. So where does the graph first hit the y-axis? So we need to look at number 1 together, just to kind of review, and I think you've actually seen this exact problem before, or maybe one very similar to it. It says, which table shows a non-proportional relationship? So all we need to do is test each of the 4 tables, and remember, I want you to prove your answer, don't just guess. And so in order to do that, you need to prove to me which one is not a proportional relationship. Let's do this one together. So we're going to do y over x. So let's test 7 over 4 and 12 over 6. When we test that, you are welcome to use your calculator. I get, let's see, that's 48, and this is 42. So are these 2 points proportional? No, they're not. Absolutely not. So that's probably going to be our answer, but we need to go ahead and check the next set of numbers. So I'm going to still use 7 over 4, but I'm going to now compare it to 23 over 10. Again, feel free to use your calculator. 7 times 10 is 70. 4 times 23 is 92. Those are definitely not proportional. So A, really, I can pretty much bet that A is going to be my answer, because nothing in this table is proportional. But in order to prove this answer, we need to go ahead and test the other 3 answer choices. So now let's look at table B. 12 over 4 and 15 over 5. Let's test those cross products. 12 times 5 in your calculator is 60. 4 times 15, well, 4 times 15 minutes is 60 minutes, or 1 hour. So that is proportional. Let's check 12 over 4 and compare it to 18 over 6. 6 times 12 is 72. Remember, you can pause this video whenever you need to so that you can review and catch up, or rewind if you need to. 4 times 18, if I put that in my calculator, I also get 72. So this one is proportional. Again, the reason we're going through every single one is just to double check our answer. We don't want to miss it just because we were a little bit lazy. Okay, next one, we're going to check 3 over 2 and 4.5 over 3. Cross products, 3 times 3 is 9. 2 times 4.5 is also 9. Check the next pair of numbers, 3 over 2. Check it against 6 over 4. 3 times 4 is 12. 2 times 6 is 12. I've tested all the numbers in this table, and the whole table is proportional. Last one. Let's check 300 over 200 with 60 over 40. 3 times 4 is 12, and then I add 1, 2, 3 zeros. Or again, put it in your calculator. You're welcome to use that. 2 times 6 is 12, and then 1, 2, 3 zeros. that one's proportional. Let's go ahead and verify that last set of numbers. I don't want to keep using my 200 and 300, so I'm going to use 60 over 40 to compare to 30 over 20. Well, I already know this is going to be proportional because if I cut my y value in half and cut my x value in half, I get this pair. But let's test it anyway. This is 1200. This is 1200. So this one is also proportional. So A is our non-proportional relationship. See all the work that we did. If you need to pause the video and catch up so that you have all of this work on your paper, you can do that. Once you feel good about number 1, I need you to go on to number 2 and do the same thing. Again, I need to see which tables are proportional, which table is not proportional, and why. When you're finished with that, you can bring me your paper. I'll give you your stamp, and then you'll be able to move on. So please pause the video now. I'd like to jump past number 3 for just a minute and come over here to number 9. So turn your paper over to the back. And we need to figure out which of the following tables can be generated from the equation y equals 2x plus 3. Okay, y equals 2x plus 3. So that is my important equation. I wish it would all fit on one line here. I wish they would format it better. But y equals 2x plus 3. So all we're doing here is plugging in the numbers in the table to see if they actually fit in the equation. And we've done this before too. I remember a bunch of you guys said, oh, this is easy once we kind of figured out what we were doing. The hardest thing about this is going to be that you need to go through every single table. So if you need to turn in your journal to a clean page and do your work there, as long as you label it so that you know what it is you were working out, that is perfectly fine. So I'm going to actually go ahead and do this on paper. Why don't you get out your journal and turn to a new page while I'm getting out my paper. Okay. So our equation is y equals 2x plus 3. And I want to check this first table. So I'm going to plug in my y. I'm going to say 1 equals, you know what, I'm going to do this over here. 1 equals 2 times x, well x here is 2, so 2 times 2 plus 3. Alright, so is 1 equal to 2 times 2, which is 4, plus 3? No. Y should be 7 if this is the right equation. So this one does not work. But I need to finish checking the table. I can't be scooting on to the next one just yet. So now I'm going to say y is 2, and then for x I'm going to plug in 3. So 2 times 3 plus 3. Well, 2 times 3 is 6, plus 3 is 9, not 2, so get rid of that one. Here, I'm going to zoom in a little bit so y'all can see a little bit better. I'm going to plug in 3. So 2 times, in this case, 4, because I'm plugging in x, plus 3. Well, 8 plus 3 is 11. So this one is not true. And then 4 equals 2 times 5 plus 3. 2 times 5 is 10, plus 3 is 13, not 4, so that one's gone. So we can get rid of choice A. Let's look at B. Same equation, so y is 1. 1 equals 2 times 0 plus 3. 2 times 0 is 0. Plus 3 is 3, so that's not going to work. Let's test the next one. 2 equals 2 times 1 plus 3. 2 times 1 is 2, plus 3 is 5, not 2. 3 equals 2 times 2 plus 3. 2 times 2 is 4, plus 3 is 7. 4 equals 2 times 3 plus 3. 2 times 3 is 6, plus 3 is 9. So none of these points in table B fit that equation. Remember to pause whenever you need to so that you can get caught up or rewind so that you can hear something that didn't quite make sense. Okay, C. We're plugging in 3 for y and 1 for x. All right, 2 times 1 is 2, plus 3 is 5. That does not work. Let's plug in our 5 for y, 2 for x. 2 times 2 is 4, plus 3 is 7. Nope. 7 equals 2 times 3 plus 3. Well, that's 6 plus 3 is 9. Nope. 2 times, whoops, let me plug in 4 here. 2 times 4 plus 3. 2 times 4 is 8 plus 3 is 11. That doesn't work either. Now, we don't want to be a lazy bum and go circle D just because the others didn't work. We need to prove it. Because if we can't prove D is correct, then there's a chance we made a mistake somewhere and we need to go back. So let's test this one. 3 equals 2 times 0 plus 3. Let's test it. 2 times 0 is 0, plus 3 is 3. So this one works. Now let's try 5 equals 2 times 1 plus 3. 2 times 1 is 2, plus 3 is 5. So that one works. 7 equals 2 times 2 plus 3. 2 times 2 is 4, plus 3 is 7. So yep. And then 9 equals 2 times 3 plus 3. 2 times 3 is 6, plus 3 is 9. So that one works too. So D is the only one that's going to fit this equation. Y equals 2x plus 3. So all we did was test every table, and it took a little while, but we found out for sure which answer is correct. And we plugged all of our tables into this equation to see which one actually goes with that equation. So if you'll go back to number 3 on the front and do number 3 and then number 10 and number 11, all three of those are very similar. Now number 11 is a little bit, I'm sorry, not number 11. Number 3, number 10, and number 17. So all of those are similar. You're going to have an equation and you need to test each table to see which table actually fits in that equation. When you're finished with 3, 10, and 17, please bring me your paper for stamps. And if you'll pause the video now, I would appreciate it. So you got your stamps for 3, 10, and 17. Number 11 is very similar to this, except you're only given one table and you have to see which equation fits it. So what you need to do is test each one of these equations to see if they match the table. So I'm going to do A with you. Y equals x plus 3. Well, up here, does 5 equal 2 plus 3? Yes. But I can't just go ahead and circle A. I need to test the rest of the table. So 9 equals 4 plus 3. 4 plus 3 is 7. So that does not work. Let's keep going. 13 equals 6 plus 3. Nope. 6 plus 3 is 9, not 13. 25 equals 12 plus 3. Should be 15. So that doesn't work either. So A is gone. Now I'd like you to finish number 11 on your own. You need to prove, I know you don't have a lot of space here, but when you get to the one that works, I need you to prove it. So next to each pair on the table, go ahead and plug it into the equation that works and prove that it actually fits. When you're finished with number 11, you can bring it to me for a stamp. Please pause the video now. Now let's look at number 16. This one is going to give us a situation, and we need to find the equation that fits the situation. Jill worked 5 hours less than 3 times the number of hours that Karen worked. Oh boy. All right, so that right there is already kind of confusing. I'm going to circle this part. This is probably most of what I need to pay attention to. Then it says, which of the following equations represents the relationship between J, the number of hours Jill worked, and K, the number of hours that Karen worked? Okay, so I need to take this English stuff and put it into math language. So Jill, I'm going to cover up these answer choices. I don't want those there. They confuse me. They all kind of look the same, and I don't want to look at them. So Jill worked 5 hours less than 3 times the number of hours that Karen worked. Okay, so Karen worked some number of hours. Oops. So we want to find out what Jill worked. Okay, so they're all J equals. So J equals Jill worked 5 hours less, okay, 5 hours less than 3 times the number of hours that Karen worked. So 3 times Karen. 3 times Karen, 3K. But she worked 5 hours less than that. So am I going to add 5 hours or subtract 5 hours? I'm going to subtract 5 hours because Jill worked 5 hours less than this 3 times what Karen worked. Now that I have my equation written, now I can see which one fits. And I see that it is F. Again, we want to put this into English instead of just math language. We want to be able to spell this out. So Jill's hours are equal to 3 times Karen's hours minus the 5 hours less. Number 12 is a lot like number 16, so I'd like for you to jump over to number 12 and work that on your own. Make sure that you show proof for your answer, and then bring me your paper for your stamp. Please pause the video now. All right, we only have 3 left. These are all graph-based. Let's jump over to number 7. It says, which of these graphs best represents the equation y equals x plus 3? So, the first thing I need to do is look at my y-intercept. The y-intercept on my graph has to be positive 3. This one cannot work because the y-intercept is negative 3. And that's not what we want. We want positive 3. So bye-bye D. This one is positive 3, so that might work. This one is negative 3, so it's not going to fit. And A is positive 3, so maybe. So I've narrowed it down now to 2 answer choices. Already I have a better chance of getting this question right because I broke it down and I narrowed it down to the proper y-intercept, positive 3. Now I'm going to look at the slope. So remember, we have y equals mx plus b. That's our format. So our plus b is plus 3. That's our slope. I'm sorry, that's our y-intercept. And the number before x is our slope. Well, I don't have a number before x. So how many x's do I really have? Well, this is 1x. And we just leave off the 1 because it's the same as saying, you know, I have 1 cat. I just say I have a cat. I don't really have a cat. So my slope is going to be up 1, right 1. Up 1, right 1. Because it's positive 1, positive x. So looking at the answers that we have A and C left. Let's zoom in really quick on A. Okay, so up 1, right 1. We ran out of space, so let's start doing the opposite. Down one, left one, down one, left one, down one, left one, down one, left one. Okay, so it looks like A probably works. Let's double check C. From this y-intercept, up one, right one would be right there. Doesn't look good. Up one, right there. Oops, I'm a little off. There we go. So this one actually goes down one, right one, down one, right one, down one, right one. So this slope would be -1. Well, that's not what we want. This slope is +1. So A fits the bill perfectly. It has the right slope, which is +1. It has the right y-intercept, which is +3. Now I'd like you to do number 6 on your own. So you have one graph here. You need to see which equation fits it. So my suggestion would be to find the y-intercept of your graph and then find the slope of your graph. What is your rise over run? Remember, rise over run. When you're finished with number 6, please bring me your paper for a stamp. Please pause the video now. Your last job today is number 20. You're given a blank graph and it says the cost of a moving van varies depending on the number of hours. That makes sense. The longer you rent the van, probably the higher you're going to pay. To rent the van, it costs $50 plus $30 per hour. So $50 plus $30 per hour. Graph this situation on the coordinate plane below. So here's our time and here's our cost. If I were you, I would start by drawing a table. And I would have time and cost. And if I were you, I would start at 0 hours. And I know that at 0 hours it's going to cost $50 because that's off the bat without driving anywhere. It's going to cost me $50. Then I know that for 1 hour it's going to cost me an extra $30. So what's that going to be? $50 just to rent the van plus $30 for that hour is $80. So if I were you, I would go ahead and continue. And once you've made a table, I mean, you could go on and on up to 10 or 20 if you wanted to. I just stopped at 4 because I ran out of space. But once you have your points, then I would graph it on the graph. Make sure that you draw a straight line, so you can use your folder or something as a straight edge, and that your line continues through the points, because here I stopped at 4, but it would be possible to rent the van for a lot longer than 4 hours. So we want that line to continue past where we stopped. When you're finished with number 20, you can bring me your paper to get a stamp for that question. And then you'll be finished with the assignment for today.